Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from May June 2024, Paper 2, Variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 7 part A says, the list below shows some SI quantities. Means the given all the quantities, they are SI quantities because they are part of SI, means part of System International. Underline the quantity that is not an SI base quantity. SI base quantity. How many SI base quantities do we have? We have 7 SI base quantities. Because most of the time when teachers also teach to students, they simply say SI quantities. But there is a difference between SI quantities and SI base quantities. We have 7 SI base quantities. For example, mass, this is one. Time, this is another SI base quantity. We have length, this is another SI base quantity. And we have temperature, so this is another SI base quantity. We have current, this is another SI base quantity. We have luminous intensity, so we can say luminous intensity. So here we have luminous intensity, and the last one, mostly it is used in chemistry, also we use in thermal physics. This is amount of substance. So these are 7 SI base quantities, so you have to be clear about this one. These are SI base quantities, so amount of substance, so simply we can say amount of substance. Now we need to figure out which one is not part of these 7 quantities. Time, this is SI base quantity. Length, it is SI base quantity. Current, this is SI base quantity. But charge is not. So simply you need to underline charge. Part B says a square solar panel with sides of length 1300 millimeters is shown in figure 1.1. Light is incident normally on the solar panel. The power of the light incident on the solar panel is 750 watts. Calculate the intensity of the light. So simply we need to understand intensity is equal to P divided by A. So this is area, normal area through the light. So in this case we have value of P, that is equal to 750 watts divided by area of this. So area in this case simply we can write down, this is 1300, this is millimeters, so this is 10 to minus 3 times we have 1300 times 10 to minus 3. So now if we simply multiply, in this case we will get 440 watts up to 2 SF. So this is our final answer. So simply here we can write down 440 up to 2 SF. Second part says the percentage uncertainty in the incident power is 3%. The uncertainty in the length of each side is 5 millimeters. Calculate the percentage uncertainty in the intensity of the light. So simply we can start with this one. This is equal to P over A. And A in this case, so let's say this side is L and this side, let's say this is W. So we can simply say this is P divided by L times W. Now we need to find out the percentage uncertainty in intensity as these quantities are multiplied and divided. So simply we can say the fractional uncertainty in intensity, this one has to be equal to fractional uncertainty in P plus delta, we have L divided by L plus this will be delta W by W. We need to calculate percentage uncertainty. So in this case percentage uncertainty, so it simply means that this side we have to multiply by 100. Now simply we have the value, so we can plug in. For this one we have the percentage uncertainty, so simply we can say this is 3% plus here we have this is 5 millimeters, so this is 5 divided by 1300 multiplied by 100 plus we have 5, this is divided by 1300 multiplied by 100. You have to be careful with the units. So this one has millimeters, so this has units millimeter, this also has millimeters, so we can use, if units are not same you have to convert them. So here Now if we solve this one, we will get 3 here, and for here we will get 0.38, and here we will also get 0.38%. so if we add them together, our final answer will be 4%. So this is the final answer. Let me explain you a little bit more about this one. If you add these three quantities together, you will get 3.76%. But percentage uncertainty should be reported up to 1 SF only. So that's the reason this is our final answer, 4%. So that's the reason. And also absolute uncertainty should be reported up to 1 SF only. Absolute uncertainty, it must have 1 SF. 1 SF. And percentage uncertainty also 1 SF. So that's the reason answer is 4%, answer is not 3.76%. Third part says the useful power output of the solar panel is 160 watts. Calculate the percentage efficiency of the solar panel. So we need to calculate, in this case, percentage efficiency. That is simply equal to useful P out. This is very important one. Useful P out divided by total P in multiplied by 100. In this case, useful P out is given, that is equal to 160 watts, and input was given to us in the last part, that was equal to 750. Now simply we need to multiply this one with 100. So in this case we will get 21%. So this is our answer, 21%. The most common mistake among students is they don't remember this one. This is useful P out. This is not the only P out. Part 4 says another square solar panel is placed so that light of the same intensity is incident normally on it. Normally is also very important. The new panel has shorter sides than the original panel. The new panel has the same power output as the original panel. State and explain whether the efficiency of the new panel is greater than, less than, or the same as the efficiency of the original panel. So first of all, we need to understand how do we calculate efficiency. We have already discussed that percentage efficiency is equal to useful P out. Useful P out divided by P in. So this is the total input power. For this question, it is given to us same output power. It means this quantity is the same. So simply we have to compare this quantity now for the two panels. For this question, it is also given to us intensity is the same. So simply we can write on power, this will be equal to intensity times area, because intensity is equal to P over area. So power is equal to intensity times A. From here we can say first of all this is panel 1, and the second panel we can say this one is larger one. So panel 1 is larger, and panel 2 we can say is shorter one. So simply we can draw here. So the second one is shorter one. So this is our second panel. So this area is shorter. For panel 1 we can say, so we can say P1, this is equal to I times A1. And for the second panel P2 we can say this is equal to I times, but A2 in this case is smaller. So as A2, so we can make this one little bit big. So this area is bigger, this is bigger. As A2 is smaller than A1, so this is A1, so you can see what is A1. So it means that P2 is also smaller than P1. So here, because intensity is the same. If this makes sense to you, now simply you can say if this P input is small, P out is the same, it means efficiency is higher. And this question has 3 marks. So we can say as area of the second panel is smaller than the area of the first panel, as the intensity is the same, so the P input for the panel 2 is lower than panel 1. So the efficiency of panel 2 is greater than efficiency of panel 1. So this is how you can compare. So in your answer you can write down these points. First of all, you can write down this point. So this will give you 1 mark. And second, you can write down this point. And third, you can say as the input for the second panel is lower, it means efficiency for the second panel is greater. So this is how you need to write on your answer. Now let me little bit clean this one and show you how you can write down your final answer. In the answer you have to write on these points. So let me clear this so you can see the answer, what is written for the answer. So this is how you can write on the answer. Area of new panel is less, 1 mark you will get. Input power of the new panel is less than the input power of the original panel, as useful power output is unchanged. Useful power output is unchanged, so efficiency is greater than the original panel. So this is how you can answer. Straightforward one. When the question is given to you, read question carefully and try to use your understanding of physics to answer the question. Always informations are there. You just need to little bit use your mind and try to figure out how to approach. Physics is a way of thinking. With time, you need to develop your way of thinking as a physicist. If you can really develop, then physics is quite easy. And today's class we will just stop here due to lack of time, but I will try to upload remaining questions in next 2 days. And if you have any questions from any paper, please feel free to leave your questions in comments and I will try to answer as soon as possible. On the channel you will see a lot of videos, about 65 papers for Cambridge A-level physics I have uploaded. If you go through them, it will help you a lot. It will change your way of thinking about physics. Ultimately, it will improve your grades. And if you need more help, you're looking for resources, please also join Patreon. On Patreon, you will see a lot of resources. And also resources on Patreon are more organized. So you can save your time and you can also find more resources on Patreon. See you in next video.